So, good evening, everyone, and welcome to this lecture. This is lecture number 6, and we are dealing with YDSE. We are writing some important points, and we had solved some question of beta. We had seen the condition for interference. We had seen the value of beta, fringe width, and all. Yes or no? Do we understand this?
Yes, sir.
We had solved some question on finding out the position of your dark and the bright fringes. Okay, we had done that. Okay, in today's class, what we will start with is a point where, if it comes, not many students would be familiar with it. Let me see, where is that point? Okay, just give me a minute. I will just get the diagram done. Otherwise, it will just take some time for me to do it. The next heading that we are going to write is angular fringe width. Angular fringe width. Angular fringe width. Now, what do you mean by this angular fringe width, bacha? Is that it is given in terms of an angle that the fringe makes, or the angular position, of the fringes. So this is what we are writing here is the angular fringe width of the central maxima, and the angular fringe width of the central maxima is this alpha. This you can see is the fringe width. So the angular fringe width alpha can be written as, in very short, it can be written as beta divided by d, or you can write it as lambda divided by small d. This is the angle that the fringe makes at the center. You can think it of in this way. This beta, this alpha beta by d is actually the angular position or angular width of the first or the central maxima. Do we understand this?
Yes, sir.
Now, if someone asks you the angular position of nth maxima, you just multiply this by n. So it becomes n times b by d, or n times lambda by small d. If someone asks you the position of minima, then you multiply it like this, 2 times m minus 1 into lambda by 2d. Do we understand this? So you just have a factor of 2. It is coming from your formula for interference fringes. It is coming from that formula. Where you have the position of dark or constructive interference as n lambda, and destructive interference as 2m minus 1 lambda by 2. Do we understand this? Yes or no?
Yes, sir.
Okay, so just note this down. I'll give you 2 minutes to note it down.
Done, sir.
Done, everyone? Okay. Then to understand this concept, I think we can do this question, and I'll give you 2 minutes to solve this question. It's a pretty simple one, and I hope that you can get me the answer for this one. Here is the question coming on your screens now. A double slit is illuminated by light of wavelength 6000 Armstrong unit. The slits are zero point 0.1 centimeter apart and the screen is placed 1 meter away. Calculate the angular position of 10th maxima. That is question number 1. Question number 2 is separation of two adjacent minima. I give you 2 minutes to solve this. Do you want any help, bacha? Or can you do it on your own?
So 1 minute.
Okay, take your time.
Sir,
Yes, bacha?
6 into 10 to the power of minus 3.
6 into 10 raised to the power of minus 3. So let me look at the answer. 6 into 10 raised to the power minus 3 radians. That is correct. Well done. Can you tell me the separation between the two adjacent minima? Remember, between two adjacent minima or two adjacent maxima, the separation is beta. Between minima and maxima, it is beta by 2. Do we understand this? So
Yes,
give me the second answer as well, then we will solve it. Well done. Yes, bacha. Shall I do it for you? Or you want more time? You can't do it? Shall I do it? Okay. So how are we supposed to do this? The first thing is you have to find the angular position of the 10th maximum. Yes or no? To
Yes, sir.
find the angular position of the 10th maxima, what do? Is you take 10 and you multiply it by lambda by small d. Yes or no? No, yes.
Yes, sir.
That is what you do. 10 multiplied by lambda is 6000 into 10 raised to the power minus 10 divided by the distance between the slits is 0.1 centimeter. You convert it into meters and you get the answer. I think you are getting the answer as 6 into 10 raised to the power minus 3 rad. Yes or no? No, yes.
Yes, sir.
To find the separation between two adjacent minima, it is equal to the fringe width, my dear friends. So it is lambda d by small d. Yes or no? No, yes.
Yes, sir.
Just do it. Lambda is 6000 into 10 raised to the power minus 10. Distance is 1 meter divided by 0.1 into 10 raised to the power minus 2. And the answer you are getting is, I think, 6 into 10 raised to the power minus 4 meters. Yes or no? No, yes. What was so difficult, bacha, here?
Yes, sir.
Everyone got this? Can I have raise hand from everyone? Okay, can you do the next one? Abhiram got it. Well done, beta. Okay, let's hope that you get the next one. And this is the next one. Okay, I hope you can see. Oh, okay, you disappeared. Anyways, let's hope that you are able to see this question, bacha. And I want you to give the answer for this one. Question number 3, I guess. And the question is pretty damn simple. In Young's double slit experiment, the distance between the two sources is 0.1 divided by pi mm. The distance of the screen from the source is 25 centimeter. Wavelength of the light that is used is 5000 Armstrong unit. What is the angular position of the first dark fringe? I give you 2 minutes to do this. Yes, bacha, anyone with an answer?
1 minute.
Okay, beta.
Sir,
Yes, bacha.
10 to the power of minus 2.
Okay, I think you might have. Okay, shall I do it? The answer that I have is not that. The answer I have is something else. Shall I do it, or you want to try again?
Yes, sir.
Okay, so I have to find out the angular width of any minima. So the formula is 2m minus 1 lambda capital D by 2 times D. Yes or no? Yes or no,
Yes,
bacha?
sir.
Just put the value of m as 1. So 2 into 1 is 1. 2 into 1 is 2. 2 minus 1 is 1. So we will get 1. 1 multiplied by lambda. Lambda is 5,000. 5,000 in 10 raised to power minus 10. D is 25 centimeter. You convert it into meters. 10 raised to power minus 2 divided by 2 multiplied by 0.1 divided by pi. So that is your answer in radians. Do we understand this? You can say your answer in terms of pi also. You can just multiply and you can give me the answer in terms of pi. The answer in the book is given in terms of degrees. So if you have to convert into degrees, you multiply it by 180 by pi. Okay, this is the answer in radians, bacha. If you want to give the answer in degrees, you want to get the answer in degrees. That is why that pi was given. You multiply this into 180 by pi, because 180 degree is pi radians. Okay, bacha?
Okay, sir.
Everyone got this? Yes or no?
Yes, sir.
Okay, I think that is enough of questions of this nature. Let us move ahead into the last topic of this. Or shall I give you one more on this? I need you to get a lot of practice. So let me give you one more, which I think. Which one should I give you? I've given you this one. I've given you this one also. You've done this one also. This one also. Oh, you've done all the questions. That's great. That's great. You've done all the questions. Well done. Then we come to the last part of this subtopic in wave optics, and this is known as shifting of fringes. So write the heading shifting of fringes. What do you mean by shifting of fringes? Oops. Why this shifting? Okay, this should not shift. The next heading that we have to write is shifting of fringes. Shifting of fringes. What do you mean by shifting of fringes, bacha? Now, in the double slit experiment, the only thing that we have done is done one diagram. In that one diagram, let me get to the diagram. In that one diagram, this is not a diagram that I need. In that one diagram, we had two slits, light going from one slit, light going from the second slit, and they were interfering at the point P. Everyone remembers this? Yes or no? No, yes. Now, what is going to happen here? I told you that the central fringe is always bright. Did I tell you that? Yes or no? Do we remember this?
Yes, sir.
But I also told you that in some cases this can be shifted, and I gave you the case where this was the case. Lloyd's mirror. I told you that the central fringe here is not bright, but it is actually dark. Did you do you remember that, bacha? I told you that the central fringe here is dark and it is not bright. So basically what it means is the position of bright fringe has been taken by the dark fringe, or there has been a shifting of fringes. The same thing could be done if I do one thing. If I introduce a glass slab here, a glass slab of thickness, let us say T, and refractive index mu. If I introduce a glass slab, this also causes a shift in the interference pattern. This also causes a shift in the interference pattern. If I put the glass slab in front of S1 or in the way from S1, the pattern will shift upwards. If I put a glass slab in the path of S2 wave or in front of S2 slit, it will shift downwards. Do we understand this?
Yes, sir.
So basically, the same thing that we have achieved can be done now in a different way. I am going to introduce glass slab in the path, and because of this glass slab in the path, the interference pattern is going to shift. So as you can see here, what I have done here is I have put a glass slab of refractive index mu and thickness T in the way of the light coming from slit S1 or the upper slit. Now, what are the things that you must remember in the shifting on fringes? Whenever a glass slab of thickness T, refractive index mu is inserted, fringes will shift. Fringes will shift. Now, fringes shifting, the second thing that you have to understand, in which direction will the fringes shift. Remember, normally if there is no glass slab, the central fringe will come at the center. Yes or no?
Yes, sir.
If I introduce a glass slab in front of the upper slit, the pattern will shift upwards. The pattern will shift upwards. If I put a glass slab in front of the lower slit, blue one, the pattern will shift downwards. Do we understand this? So pattern shifts, and where does it shift? It shifts in the direction of slab. It shifts in the direction of slab. If you put a slab in front of the upper slit, it will shift upwards. If you put a slab in front of the second slit, the downward slit, it will shift downwards. Do we understand this? Yes or no? You'll have to note
Yes,
this
sir.
down. You have to keep that in mind always. I will give you time first, understand, then I'll give you enough time to write it down. Don't worry. Now, it shifts. We have also seen in which direction it shifts. How much is the shift? So there are two ways of remembering the answer. The shift is mu minus 1. Please first see it, then I'll give you time. Mu minus 1 into T multiplied by D by D. This is one way of remembering it. The other way of remembering it is, instead of writing it as D by D, you can write it as mu minus 1 T into beta, the fringe width, divided by lambda. So these are the two ways in which you can remember the shift. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this? Now, sometimes they ask you or they give you number of fringes shifted. Please see it, then you can write it. Number of fringes shifted. How many fringes are shifted? So number of fringes shifted, you know the total shift is this much. If you divide it by the fringe width, you will get the number of fringes shifted. So number of fringes shifted, n will be shift divided by fringe width. So the formula becomes mu minus 1 T by lambda. Mu minus 1 T by lambda. This is the formula for number of fringes that are shifted. Do we understand this? Number of fringes that are shifted is mu minus 1 into T by lambda. Sometimes they will give you number of fringes that are shifted. From there you can find out the thickness of the slab. Thickness of the slab ka formula will become n times lambda divided by mu minus 1. N times lambda divided by mu minus 1. That will be the formula for the number of fringes that are shifted. I'll give you 2 minutes to note this down. Note it down aram se.
Done, sir.
Everyone has noted it down, bacha?
So,
Okay. You need to remember this formula quietly. Do not make mistake, because if you make mistake in one thing or the other thing, you might use a wrong formula. So now based on this formula, I am going to give you a couple of questions. I hope you can solve those questions. And this is the question that is coming up. Solve it. A thin mica sheet of thickness 2 into 10 to the power minus 6 meters and refractive index mu 1.5 is introduced in the path of the first wave. First wave means the upper wave, upper slit. The wavelength of the light used is 5000 Armstrong unit. How much will the central maxima shift? I'll give you 2 minutes to do this. Yes, bacha. Can I tell you? Or you are trying? I'll give you one more.
Sir,
Try. Okay,
Sir,
okay.
option A.
Option A, two fringes upwards. That is correct. Well done. Two fringes upward. What about the others? Did we get the answer? Well done. I'm so happy. Well done. Two fringes upwards. That is the answer, my dear friends. Anyone else got the answer? I'll give you 1 more minute. I want all of you to do this. How to do this? Anyone?
N equal to mu minus 1 T by lambda.
Huh? Yes, bacha? How are we supposed to do this? So you just have to apply the formula straight away. What is the number of fringes that are shifted? You can just apply this formula. Did you apply this formula straight away, bacha, or no?
Yes, sir.
But you apply
yes,
the
sir.
formula straight away and you get the answer. The formula is the number of fringes shifted n is equal to mu minus 1 into t divided by lambda. Mu is 1.5, t is this one, and lambda is 5000 Armstrong unit. Remember, Armstrong unit, you have to multiply it by 10 raised to the power minus 10. All of you understand this, yes or no? And it is put in the path of the upper ray, so it will shift upwards. We understand this, yes or no? No, yes.
Yes, sir.
Everyone got this answer now? Everyone understood this? Can I have some raise hand from everyone who understand this?
Sir,
Okay, can I give you one more question based on this?
Yes, sir.
Okay, let me see where the question is. Okay, the question has gone somewhere else. Just give me a couple of minutes so that I can get to that question. Yes, it's coming here now. Now, here. This one. In YDSE experiment, D is 1 mm, capital D is 1 meter. Now there are two slabs inserted. Now remember, if you insert slab in the upper slit, it will shift upwards. If we put it in the downward, it will shift downwards. Okay. If you put it in both, you see what is the upward shift, you see what is the downward shift, and then you find out the net shift. Do we get this? 2 minutes you have. Yes, bacha, any answer? Shall I wait?
1 minute, sir.
Okay, sir.
Sir. Sir.
Yes, bacha. It just requires a bit of calculation, I think. Yes, bacha.
1.5 nanometer.
1.5 nanometer or millimeter? Okay, you might have done mistake with
Millimeter, sir.
millimeter. Does it shift upwards or downwards? Well done, girls. Good job. Well done. Really well done. It shifts 1.5 millimeter upwards or downwards? Okay, let us find the shift. Let us find the shift upwards. How much is the shift upwards? So mu is 3. 3 minus 1 into thickness is 1 into 10 raised to the power minus 6. Mu minus 1 into t into capital D by small d. Yes or no, bacha? Capital D is 1. Small d is 1 mm. So 10 raised to the power minus 3. Yes or no?
Yes.
That is the shift. So it will come, I think, 2 mm upwards. Yes or no, bacha? Yes or no?
Yes, sir.
Shift downwards. Let us put the formula for shift downwards. Mu is 2 and thickness is 0.5. So it will become 2 minus 1. Mu minus 1 into thickness is 0.5 into 10 raised to the power minus 6 into capital D is 1, small d is 10 raised to the power minus 3. And I think this is coming as 0.5 mm downwards. Yes or no? No or yes?
Yes, sir.
Well done, bacha. Then for the net shift is 1.5 mm upwards. Do we understand this? Yes or no? No or yes?
Yes, sir.
Well done. Then we come to the last question for this particular topic, and it is coming. This question actually came in one of the JEEs, JEE Advanced. So I'm giving you this question. Let's see. Remember, all questions are simple. We just understand the concept. All questions are simple. I want to make a point here, and that is why this question is put. So this is the question, my dear friends. And remember, this question came in one of the JEEs. In a YDSE, fringes are observed by using light of wavelength of 4800 Armstrong unit. A glass plate mu is equal to 1.5 is introduced in the path of the upper wave, and a glass plate of the same thickness, remember the thickness is same, of 1.8 is introduced in the lower one. The central fringe now takes the position of fifth bright fringe. The thickness of both the plates is same. What is the thickness of the plate? Do you understand the question? Yes or no? No or yes? You have 3 minutes to answer it. We
Sir,
yes, bacha.
option B 80 micron.
Option B. Let me just check. Just give me a minute. I think that is correct. Let me just check. Option B, 8 micron. That is correct. Well done. Very well done, beta. Well done. I was not expecting. Well done. Good. How did you do this? So, You find the shift due to the first plate. Let me call this shift upwards. Shift after upwards will be mu is 1.5 minus 1 into T by lambda. Yes or no? Then you find the shift downwards. Shift downwards is 1.8 minus 1 into T by lambda. Yes or no?
Yes, sir.
Then you find the net shift. You subtract. Downwards is more, upwards is less. If you subtract, you will get 0.3 T by lambda. Yes or no?
Yes.
And 5, the central fringe has shifted to fifth maxima. So that means this will be equal to 5 times beta. Yes or no?
Yes, sir.
5 times beta. Here I have forgotten to write beta, and that is why I'm looking all confused. I did not write beta here. So this is 5 times T beta by lambda. Beta will get cancelled, and you can get the value of thickness of the plate as 5 lambda by 0.3. Yes or no?
Yes, sir.
That gives us the answer, and we end up with the answer. The answer that you will get will be 8 into 10 raised to the power minus 6 meters. Yes or no? No, yes.
Yes, sir.
Well, then that finishes our wave optics ka part number 1, where we are seeing Young's double slit experiment. I hope we have done almost all types of problems that were possible that can come in your exam, and there is nothing that is left. I've told you all definitions, everything, every important point has been given to you as notes. So I hope that you have understood this. In the next class, we'll start with diffraction. So meet you in the next class. Take care. Have a good day. God bless you all. If you have any doubt, please ask. And I'm very happy with the way you are thinking. These questions are tough ones. It will only come when NEET is very tough. But since you could do this, I'm very happy for you. Remember the small formulae, and I know you are going to score heavily in physics. Take care. Have a nice day. God bless you all.